All right, thanks again everyone for joining. Again, this is Rob Flannery. I'll be your presenter today for getting the most out of your Infor applications by leveraging Amazon Web Services. A little bit about what we're going to cover today, kind of an introduction or overview of AWS, as well as Infor's cloud, their application offerings, and how that ties into AWS. Some potential migration strategies from moving various workloads to the cloud, as well as some sample use cases of leveraging AWS services and technology to support your Infor applications, as well as any other applications in your enterprise. At the end, we'll open it up to any questions. You can just send those to me in the chat. First, a little bit about Intellias. We're headquartered in Dallas, Texas, and just recently opened offices in Chicago, Illinois, in the downtown area. We've been around in the Infor space since 1999 and are also listed as an Infor Alliance partner. On staff, we have a number of full-time Infor and AWS certified consultants who help with some of our various offerings, such as cloud services, Infor implementations and upgrades, technical services and application consulting around any of your Infor needs. Intellias also has a number of software offerings which supplement core loss and application. Some of the popular products that you may have heard of include benefit add-ins and job automation. Just a quick overview on AWS. I'm sure most everyone has definitely heard of this offering, but what is it and how do our customers using it? It is a public cloud provider. One of the benefits of looking at a public cloud provider such as AWS is the global reach. Services are reliable, scalable, and very secure infrastructure, which is hard to replicate on a smaller scale on your on-premise environment. There are a number of services offered by AWS that should be classified into two separate categories: infrastructure as a service and the platform as a service. When we talk about infrastructure and platform as a service, I like to look at it in this chart, comparing it not only to on-premise, but also to software as a service offering, which is really where the Infor applications will come into play. Just based on this color chart, if you imagine the lighter color being your responsibility as the customer, and the darker color boxes being others' responsibility, being vendors like AWS or Infor, you can see kind of what the difference is in breakdown. An on-premise environment, you're responsible for everything, starting with the physical location to where the servers are, the networking, storage, and servers that support that, all the way up to your data and applications that your end users are interacting with. But the infrastructure as a service, that physical resource, is really the responsibility of someone like AWS. You could deploy virtual servers and technology into their cloud. At that point, you're really just responsible for managing the operating system on up. The two that we want to focus on today are really fall into the category of the platform as a service and the software as a service. So with the platform as a service, you're not really purchasing an application. It's more a technology platform where you can develop and deploy code, but you're not really responsible for, or you don't really have to be aware of, and the underlying server or compute resources that are responsible for running it. And in the software as a service environment, the same thing is kind of true, taking it yet another step further, where the vendor is responsible for managing all the application patching and support, and really you're just responsible for using the core application. So AWS really falls into these two main categories, where Infor is on the right and the software as a service model. I'm not going to go through the benefits of the cloud. There's a number of things you can read out there on why you may look at the cloud versus another on-premise provider, but really want to focus on why AWS. There's a number of other cloud providers, Azure, Google Cloud. You may already be using those in your organization or at least investigating them. But why are we focusing on AWS today? There's three main reasons, the top of which is they are the leading cloud provider. They have the largest market share over any of the other cloud providers. And they also have a tight integration with Infor's cloud. mainly because Infor runs all of their cloud offerings within AWS. They don't have their own proprietary cloud platform. They're using AWS infrastructure to host their applications. So if you're an Infor Cloud subscriber, you're indirectly already an AWS customer. There's also some integrations built in to deliver tools like Infor Process Automation and Ion, which make AWS a smarter choice. Mainly, there's hundreds of services here to help power your enterprise applications. These services, there's numbers of them. We don't have enough time to talk about all of them today, but I want to focus on a few that I think are going to help customers running Infor in the cloud and figure out better ways to leverage it and take advantage of what AWS has to offer. So the key services to focus on really fall into these 5 categories: networking, compute, database, storage, and analytics. Again, AWS has hundreds of these services out there. We're not going to talk about all of them today, so I kind of picked 10 that I think are important, either foundational services or key services for Infor customers that I think could provide a lot of benefit if you're running your Infor apps in the cloud as well. So to go through these at a high level first, and then we'll take deeper dives with the use cases. On the networking side, this is really your foundational element of the cloud, your VPC, your virtual private network in the public cloud. So this would be how you organize and pool your resources on the cloud network. The Direct Connect, there's a number of other ways to do this, but a popular service called Direct Connect is really responsible for connecting your on-premise data centers to the cloud. So, you know, the reality is you're always going to have most likely something running on-premise. If you have things running in the cloud, they probably need to talk to things on-premise. So Direct Connect is one of the methods we can use to connect those 2 networks and allow for seamless communication. On the compute side, 2 main categories. EC2 is really your classic when you think about, you know, running virtual machines in the cloud. EC2 is Amazon's solution for that. You can spin up virtual Windows servers, Linux servers, so on and so forth. Important, but kind of a basic offering as far as cloud computing is concerned. One of the cooler topics and services that we're going to talk about today would be Lambda. And so that's the idea of serverless code execution, where you can harness compute power in the cloud, calling different scripts or code written in popular programming languages, but not really be responsible for or have to manage or really even be aware of what type of servers are running the code underneath it. On the database side, there's 2 popular managed database services, the RDS for your standard relational database like SQL or Oracle, and then Redshift is a managed data warehouse offering all within the AWS cloud. For storage, there's 2 key storage solutions for object and block storage depending on what your needs are. And then on the analytics side, I think these are key when you start to talk about querying, accessing, reporting on data, using data in the cloud. We'll talk about Amazon Glue and Athena. So how does this all fit with Infor? Infor does run their own cloud, so if you subscribe to Infor's software as a service offering, you'll be running apps in AWS, but not really responsible for managing them. They're trying to bring customers into the cloud platform, and really as a vision, or as a company, their vision is to focus on the cloud-first strategy. So applications are engineered for the cloud and being built for the cloud first, with a number of different deployment options available thereafter. So they do have a bundle of core SaaS offerings. The on-premise is still supported, but I would say not really ideal at this point in time. One of the huge benefits of moving to the cloud would be the economies of scale. So the idea with Infor, the more cloud customers we have, the more Infor cloud customers we have, more efficiency and cost savings can be passed on to the customer. The idea being, effectively, if everyone is running the same version of the application in the same place, it's easier to manage, devote effort to building, patches, enhancement requests, and all of that type of thing for a core group of customers, versus having to deal with a number of different customers on different versions, on different platforms, kind of all over the place. And of course, with the cloud, generally you're going to see improved performance, availability, and security versus what you could replicate with your on-premise data centers. One of the other things I like to point out is that Infor has had a number of investments in their company recently, over $3 billion since 2017. So they're putting a lot of money and effort into building this cloud platform. I generally like to, kind of say to customers to follow the money. If they're putting all their money into building a cloud platform, myself, I personally, assuming it fits my business needs, would rather align myself with that versus trying to go and stay the on-premise track where you might be supported, but could be missing out on features and functionality because everything's going to the cloud first. So how do we get there? These migration strategies are very general, kind of broad, going over in a lot of different places. But in the scope of Infor, which ones do we choose? How do they fit? They can also be applied to any other workloads that you might have running on-premise. So it doesn't really just have to be Infor. But going through them fairly quickly, rehosting would be where you lift and shift. So in this type of environment, you might take virtual Windows servers you have running on-premise today, move them to AWS, and run virtual servers in the AWS cloud. Same platform, just running in a different location. With replatform, sorry about that. With replatform, it's similar to lift and shift, where we're bringing things into the cloud, but we may be looking at potentially different operating system, potentially a different database platform. Maybe we're running the iSeries today on-premise, and we're replatforming to run on a Windows server in the cloud. Different reasons for that, cost potentially, performance, different options you may have. Could be a number of reasons to replatform. Repurchase will be where you go and kind of buy a whole new software solution to meet your needs. This could be in the form of software as a service, replacing some on-premise dedicated workloads you have running in your data center. When you talk about moving to Infor Cloud, it's usually a combination of the two. Repurchase is a little misleading because if you're running Lawson today and you go to Infor version 11, it's really the same vendor, so you're not changing vendors. But the application is different and the platform is very different. When we talk about running multi-tenant software as a service model, it's a very different solution than how you may have been managing your applications on-premise. Refactor is similar, where you're basically rebuilding the applications to take advantage of functionalities in the cloud that are not possible on-premise. So when you talk about some of the managed infrastructure, serverless technologies, basically rebuilding your applications to support those using cloud-native solutions versus just simply moving your server and workload into the cloud as is in the lift and shift model. Where retainment comes into play is if you choose to basically stay on-premise. The cloud isn't going to work, so we retain our current solution and move forward from there. And for retire, I think this is an important one to look at just because applications change so much and new features and functionality come out. You may find that you don't need some of the things you've built, some of the customizations, some of the databases that are running today to support your on-premise Lawson environment because there's out-of-the-box functionality that handles it in the cloud. And so that's where the retirement comes into play, to retire old assets that are no longer needed, given the fact that newer solutions meet the business needs. Our recommendation when looking at those types of strategies, looking at Infor's product offerings, to take a hybrid approach. So look at Infor software as a service offerings very closely, align yourself with that product, but then supplement as needed with AWS services to fill any gaps you might find. The key here is moving to the cloud should not mean you're losing out on functionality. The use cases we'll go through kind of talk about common questions I get from customers about, well, I do this today and I don't see a like-for-like exact solution in the future state. There might not be an exact solution, but a lot of the times there is a solution and it could be a better solution. Either it's cheaper to run, faster to run, what have you. There's lots of different options and we'll go through some of those today. So for use case number one, what we'll have here is that an organization is currently running Infor Lawson on-premise with several customizations that are dependent on a database that may or may not be on the same instance as Lawson today, but we've determined that we still need that database in the future state. So if we move into a multi-tenant cloud SaaS platform, you're not going to have access to the database. You're not going to be able to query it. You're certainly not going to be able to create any custom tables in it or custom objects. So what do? We had leveraged our Lawson database in the on-premise environment, and we need some type of database in the cloud to be able to support our business users and operations. So the primary solution we would recommend for that would be the Amazon RDS. So this is the relational database service offered by AWS. This is a very basic solution in terms of an architecture diagram, but effectively you would launch an RDS instance within your VPC in AWS, and then if needed, we could use that direct connect or site-to-site VPN to allow on-premise servers, client PCs, what have you, ability to connect to it from the local network. A little bit about the RDS. This is, again, a relational database service which allows you to provision relational databases in the cloud in just a number of minutes. They support a lot of industry standard functionality and features, such as encryption of data at rest. We can still handle Windows authentication with your on-premise directory server, assuming it's a SQL RDS. And things like always-on availability groups or high availability, read replicas, all of that is supported out of the box with the RDS. Why you might look at RDS versus another on-prem database solution or even a virtual machine running a dedicated SQL instance, I think the key here is the word manage. So with the RDS, it is a fully managed solution. That means the backups, software patching, any automatic failure detection and failover recovery is all handled for you without really any input, intervention, or need for you to deal with it at all. So you're paying a little bit more for the service, but it basically makes it so that you no longer need a DBA. You spin up and launch an RDS instance, you connect to it with the normal tools you're used to managing databases with, and then from there you're basically just creating databases, analyzing your data, working with your data, and kind of leaving all the overhead of managing that database behind. It can be cost effective, maybe not when you look at it, short term. On paper, it is more expensive per year or per minute or hour, however you want to measure it, potentially, than running a dedicated full-on instance of SQL yourself. But you also need to think about the management costs and the overhead costs. With the RDS, someone else is handling that and it's included in the price. So big picture or longer term, this can actually be a more cost-effective solution for you to handle and manage databases in the cloud without having to have a dedicated DBA to watch over them. Another thing with the RDS is it's highly reliable, available, and durable. So for disaster recovery scenarios, all of that's handled right out of the box, where the automatic failover will come into play, making it so that your applications can have high uptimes and usability. There are also a number of platforms supported. So when we're building an RDS, what does that look like? Here's a couple screenshots of the management console. Again, you can really go through this in minutes and have a database launched and running in the cloud. You can see Oracle and SQL Server. These are key platforms for our Infor customers. But there's a number of open source alternatives that are also here as well. And then the Amazon Aurora, that's the one I have selected in the screenshot here. This is the AWS kind of proprietary take on some of the open source SQL alternatives. So when you're picking this out, you pick your platform, your database location, regional versus global. So in AWS, the concept of a region is a regional geographic area. So like in the US, they have an eastern region and a western region. In other countries, there's a number of regions, and that's really referring to a number of data centers in a common geographic area. So you can pick to do a regional deployment or a global deployment. So if you have users across the globe, you have users in Asia, users in Europe, users in the US, a global deployment might make more sense because the users will have really better performance on the database if it's deployed globally versus in a specific region with various latencies and things like that. So you pick your platform, pick your type, like SQL Server, you can do 2012, 2014, 2016, different versions of Oracle. Pretty much anything you can think of will be supported there. And then the next thing to do is basically pick the name or the instance name of the database and define a master user. And really it's just a couple more clicks to get the database provisioned. You're picking a size. Obviously, the bigger the database or the more resources it takes out, the more expensive it's going to be. But that's all configurable, and so you can build it to really suit your needs. And then that availability and durability. So you have the option of turning on mirroring, always on, replication sets. Again, that probably makes sense in a production environment so that you have DR and backup plan in place. But in your development and test environments, maybe you don't need that additional cost. So all configurable, can fit any really various needs you may have with your database. The second use case we'll go through is that an organization is upgraded to Infor's Cloud Suite applications, but still needs the ability to run SQL queries for ad hoc reports and interfaces. So this really comes into play with a customer who might be running Infor Cloud Suite multi-tenant. In the multi-tenant environment, you do not get access to the database. You cannot run SQL queries directly against the database, but that's obviously still a need for customers to be able to support the business. So this solution is a little bit more complicated, and I think as you get more involved with AWS, you'll see it's really a combination of services that are put together to create a full solution. Still very simple, very basic. We'll actually go through a live demo of this one. But you'll see here there's really 4 things in this picture versus the one we were just talking about, RDS, as an alternative to your on-premise database. So here we're going to deal with 4 different services. The Amazon S3 Simple Storage Service, which is used for object storage in the cloud, things like flat files, images, things like that. AWS Glue, which is an ETL tool that also discovers and creates a schema for objects that are stored in Amazon S3. And then we have 2 different ways to get at that data, right? We've put it in a storage system, we've used Glue to build a schema, maybe transform it, and then we're ready to query it. So there's 2 different options there we'll look through. All of these delivered out of the box with AWS and can help support Infor. The Athena would be the serverless interactive query service, or if you need a more robust solution, Redshift, which would be a fully managed data warehouse. Similar to RDS, which is a fully managed relational database, the Redshift kind of takes that one step further. If you need more power in a true data warehouse solution, you would be looking at Amazon Redshift. So this solution, we're going to focus on Infor data, but again, this isn't Infor specific. So the nice thing with this type of solution would be that it can be architected to really support data from all these systems in your enterprise. Building a data lake, data process through AWS Glue, and then putting it into some sort of analytical tool or data warehouse to be acted on by the business users. So how this diagram looks, on the leftmost side we have the data sources. So obviously we need data to collect before we can do any analysis on it. And that can come from a number of sources. I just picked 2 here to keep it simple. We can pull things from on-premise databases. We can take application data that the end users key into the ERP. Whatever that might be, we need to have it entered, collected, and then we will put it in what's called an S3 bucket. So that's that object storage solution. Once we have it in AWS and S3, the AWS Glue tool will be used to potentially transform it, but then also crawl it and create a schema. So we have a flat file. The schema will basically tell query tools how the data is organized, the schema of what that table should look like. After Glue processes it, it's ready for analysis, to be imported into Redshift for further processing, how we would traditionally think about accessing data for SQL. As far as Infor is concerned, I do want to call out this one feature. This is going to be a key feature for any Cloud Suite customer. The replication sets were delivered with Landmark 11, so all Landmark applications, assuming you're on Landmark 11, have the capability to create replication sets. Replication sets effectively allow customers to configure extracts from pretty much every table in the system. So all your landmark applications, all the underlying tables for those landmark applications, IPA, GHR, talent management, FSM, can have replication sets created to pull that data out into some type of flat file for processing. All of this is built in, delivered out of the box. The extracts can be full, so we're doing full table scans, or they have the ability to do incremental polls based on timestamp, so a delta. Only the transaction since the last time I ran, for example. And then those extracts are exported to the local file system. If you're running on-premise, we can FTP them or use the IMS to move them other places. So we'll look at the replication sets and then do a live demo of kind of how that would work and how we can access it and process the data within AWS. So the first place we'll look is the admin console. So the admin console is a web application delivered with Landmark 11. I'm in the GHR application on my sandbox. This is where we're going to configure and access the replication sets for processing. So under here we have a replication set menu. I'm just going to go into one of my sample replication sets to kind of show what the setup is like. Obviously we pick a name, that's just user defined. The export format, so do we want the data in JSON, CSV, XML, different options there. And then where are we going to put it? I have an on-premise server running, so I'm just putting it to a local directory, but in the cloud you'd be selecting the IMS or FTP option to automatically transfer it to S3 for you. Once we set that up, we pick our tables. So there's delivered templates out of the box, but the idea here is you know what tables you need data from. We tell the system which data tables to pull from, and then in the case of employee, you look here, you can see all the other fields that are also listed. So we pick which tables, which fields, and then also whether or not we want historical data. So this is a big option here because reporting on the historical audit data in some of the newer applications can be pretty tedious with traditional SQL. So these replication sets can be a great way to extract the data out, putting it into a logical kind of stack format that makes it much easier to process for your reports and interfaces. So once we've picked our tables, the fields within those tables that we want to pull, and define the replication set as a whole, and we have a export location created and configured, we would then just run the replication set here, and it will kick through, and in this case, it's set to pull deltas. So, for example, if there's no new employee data since the last time the replication set ran, it's not going to pull any records for the employee file. It only pulls what's changed. And this can be run as schedule on whatever frequency you really like, and this would be how we're pulling data out of the system for further processing. So on the server, here's a little kind of peek of what this looks like. Here's my replication set export. It creates a file for each table and then increments data for each table or each subsequent run. All of this is compiled onto the server, and then in my case it's local, but we could set up an FTP or IMS connection to move it for us. I'm doing this manually because I think it helps explain the process better, but in a real-world production scenario, the extract, transfer, and load to AWS would all be automated. So now that we have the data pulled out of the system, I'm going to use this folder as an example. We've organized it by table, and so each table has its own directory, and then within that directory is the extract of the database. So if you look here, this is JSON format, so it's not terribly easy to read for humans, but you can see the field and the value. So employee, and then the employee ID, so on and so forth. So we're going to take that data, and we're going to create a bucket in S3 and upload it. So to create an S3 bucket, it's pretty simple, quick steps. So I'll create a bucket called Replication Set Webinar Bucket. And we'll pick the region. Ohio is a good one for me. If you were running your app somewhere else in the world, you might want to pick a different region. But the rest of these defaults, we can just go through. So I created my bucket, and now I'm going to upload files. And this interface, I mean, I don't know if it's a great comparison, but a lot of people have familiarity with it. Kind of reminds me of how we would manage files in like SharePoint. So you're just taking it from your local file system, dragging and dropping it, and then it's going to upload it into our bucket for processing. So if you look here, you can see all my files are uploaded now to the cloud in the same format that I had on my PC. So now that they're in the cloud and they're in my bucket, what I need to do, going back to this diagram here, we're here. So I've used replication sets to extract application data. I've put my data in a S3 bucket, and now I need to process it so that I can query it. So we're going to go ahead to the AWS Glue solution, and we're going to add a crawler to do just that. Now, adding a crawler is going to allow Glue to discover and realize the schema of that data for further processing. This would be a one-time setup, so this wouldn't be something you're doing every time you want to access the data. This is initially, staging the bucket, defining the replication set, defining the crawler. It's one-time initial setup, and then from there on out, everything would run in an automated fashion per the configuration. So we'll just give it a basic name here, replication set crawler. So now we've created our crawler, really we just specify the bucket that we just created that contains all those JSON files, and we tell it to use that for its data store. We give it authority to read from that bucket, and then we specify a frequency. So the crawler really only needs to run every time the structure of the files in the S3 bucket has changed. So for the purposes of this example, we can really just let it run on demand. But if you were constantly or potentially adding additional tables, additional fields into your replication set, which is very realistic, then you might want your crawler to run on a more frequent basis. But for purposes of example, we can just do this on demand. So we're going to have it create a new database schema. I'll just call it replication set. Replication set webinar DB. And so as it crawls those files and creates the schema, they'll be added to this new database. That's basically it. So now that we have our crawler set up, we're going to run it. It'll take about a minute to run, and you can see the status in real time. So the status is currently starting. And as it runs, you can see these two columns here, tables updated and tables added. So right now, this crawler has identified 0 tables, and by the time it runs, I would expect it to find 5 tables, and that will correspond directly to the 5 files that I've uploaded to S3. If I added another one, it would find 6, 7, 8, so on and so forth. So we'll let this run to completion, and then we'll take a look at the schema that it generated for my database. Again, in a production environment, a live environment, this would be running automatically, no reason to come in here and monitor it. So we have our crawler, it's stopping, it ran for 43 seconds and it found 5 tables. So if I go into my databases now, I should see a new one, replication set webinar DB, and all the tables that were found. So this corresponds again to the 5 folders I uploaded to S3. If you go in and look at the table, you can see the schema it's defined. So it's identified all the fields in that flat file, as well as the data type, and now we're able to query it. So if I go into again, there were 2 solutions here. So back to this diagram, we're in the analyze phase now. What do I need to do with that data? How do I need to access it? That will really drive the solution we use here. That Redshift is a fully managed data warehouse. So if you need advanced massive data processing, adding that Redshift component makes sense. If you're just looking for quick ad hoc queries and reports on the data and analysis, Athena, which is the serverless query solution, is really your best bet. We could also load the data to that RDS, which I talked about in the last use case, if you wanted to be managing it in a full-blown SQL Server solution. That's fine too. Kind of just depends on your needs. So within the AWS console, and this is all online, I'll pull up Athena, and you can see Athena's identifying all of the databases that Glue found and populating them in the drop-down. So again, we see these 5 tables available, and then we have our query window here. So in my query window, this is just standard SQL. So if I want to select all from Replication Set webinar db.employee and execute the query, the result set is available. So this looks like any standard output you'd have in a normal SQL developer tool. Obviously, this is a very basic query, but you could put advanced operations in there to massage and format the data as needed. Any ODBC connection is supported. So now that we have this data available, we can leverage Athena to connect via ODBC to any other BI or local query client we have running. And again, if we need further data processing, we could put it into one of the managed relational database or data warehouse solutions within AWS. So for use case number 3, the requirement is that an organization needs to build an interface between 2 applications running in the cloud. The delivered tools such as IPA, ION, or et cetera from Infor might certainly work, but there's a fear they could not or may not integrate well with non-Infor applications. So if we're working with and integrating with other systems, IPA is definitely a solution, but I think running everything within AWS, there's possibly other services that may work better, faster, cheaper than what we had previously had available. So that's where AWS Lambda comes into play. There's a number of different ways to work with this, but I picked Lambda in this example because I think it's one of the more powerful solutions. So Lambda is a serverless compute service. What that means, really simply, is that you can run code without deploying or managing any servers. Kind of like the last solution that I just went through with the query language, I was able to execute all of that and run queries against the data without ever specifying a server, connecting to a server, needing to worry about the servers. So that serverless theme is very common when talking about some of the cloud computing power. So Lambda allows you to do that and execute common scripts or code, different programs, as well as integrates natively with many of the other AWS services. In some ways, it's kind of like the backbone of integrating and automating processes within AWS. That usually means it could be a great tool for building integrations with other databases, web services, storage solutions within AWS, within Infor, or on-premise or anything like that. So with this use case, this diagram here, again, we're starting with the same thing. We may have application data being entered. We may have third-party application users communicating with our cloud via the API gateway. All of that data is being collected in the AWS S3, Simple Storage Service. And then the nice thing with Lambda, or how that comes into play, is previously we were querying the data, but what if we need to do other things with the data? We're not just building reports. We need to notify. We need to queue messages. We need to interact with another database, and that's where Lambda comes in and kind of takes that one step further. So Lambda can be configured and built to interact with and be triggered directly from events that occur in S3. So like when I uploaded all of those files, we can build a function which executes Lambda code that sends an email, that processes the file, it parses it, and sends different emails, or whatever that might be. Loads data to a database. So Infor does deliver comparable functionality to a lot of this. IPA and ION can handle a lot of these processes. But looking at services in AWS can be nice because it works well and plays well with other applications, and you're kind of not dependent on the Infor components to make all of that work. So with the Lambda serverless technology, I think there's 4 key points that I think are important to remember. So with serverless, really what you're doing is you're developing and deploying code without ever worrying about the server. So the developers don't have to worry about the underlying infrastructure, potentially any of the networking. They're just writing their code, deploying it, and testing it. So you're simplifying the development process and streamlining it. Another thing is cost. So developers are only charged for the space and compute power that they're using, which can be a huge cost saver reduction. When you think about building and deploying servers, let's say we build a server that we know needs to take 50,000 active users at a time, but maybe it's only 50,000 active users during open enrollment, 1 month a year. The other 11 months, you're still paying to support that massive server, but the workload might be reduced by 90%. So when you use some of these serverless technologies for compute processing, you're really only charged for what compute resources are used. So if your code's not being executed, you're not paying for it. You only pay for the number of executions that occur, or the number of compute power that's being used as you use it. The serverless idea also really means your architecture is inherently scalable. So when you have that smaller workload on the server, we can handle that. But when you have a massive workload and you have 50,000 active users on the system, something like that, whatever it might be, it should automatically scale up and be able to process that. You don't need to get involved. You don't need to talk to your infrastructure team. It all is handled via the serverless infrastructure. And then another big thing that I like to call out is, although this is proprietary to AWS, the languages used to build Lambda functions are very common programming languages: Python, Java, Node.js. The key here is it should be relatively easy to find support and development talent with these common popular languages. Some of the proprietary solutions you may have been working with, not so much. There's not readily available training, documentation, or support for some of the proprietary workflow solutions, or not as much as you might be able to find for these common industry standard languages that are built into some of the serverless functions in AWS. So it's just another note to call out. So let's say you think this all sounds good, and Infor, you're looking at the Infor cloud, and you might potentially be running some other AWS services, but the reality is you're still likely going to have always an on-premise data center. And that's not a problem. It's a very common deployment configuration. The short answer to that, or the easy answer, is that AWS has services to support the integration out of the box. So we talked a little bit earlier about the direct connect or VPN tunnel. What those do is effectively make it so that resources, both on-premise and the cloud, are able to talk to one another. They're on the same network, I guess, so to speak. So it's very common, very well supported, to have a connectivity between the AWS VPC, Virtual Private Cloud, to your on-premise data center and network. One important thing is we didn't really talk about any specifics of these features within AWS, but we definitely need to talk about the pricing model. The key here is it's very transparent, but the mindset is different. So it's a shift from focusing on capital expenditures to operational expenditures. We're no longer needing to get approved budget to buy $20,000 worth of servers. You're paying on an ongoing as-needed basis for the compute power resources that you use as you use them. So the pricing model can really be broken down into 4 main points. It is pay-as-you-go, so you pay per hour, per second, per cycle, or whatever it might be of a compute resource. So for example, if you're running a virtual server, running Windows 2016 in AWS, you're going to pay a certain amount per hour. When you shut down that resource, you stop paying for it. So you pay as you go, and you only pay for what you use. That leads into the flexible functionality of it. There's different ways to save money in turning off certain features on scheduled times, buying different packages of compute power, bundled different ways. It's a very flexible pricing model that has a number of options to suit whatever your organizational needs. volume discounts. Basically, I mean, it's different on each service, but the more you buy or the longer you commit for, there's a pretty significant cost savings. So if you know you're going to be running some workload for at least a year and you can commit to a year of payment, there's a pretty substantial discount when you pay for it and buy it up front. And I think the other cool thing that AWS kind of touts and is very transparent about is you save as AWS grows. So obviously as they're growing, as they're building, as things become faster, more efficient, and cheaper for them, they generally do pass on some of those cost savings to the customer. And so as of when I put this PowerPoint together, the comment was they've reduced their prices 67 times since 2006 and have never really had to raise them. And that's just a matter that, dealing with the economies of scale, and AWS is passing on savings to the customer where they can. So in summary, I think there's 4 key takeaways from the webinar. First and foremost, I think it's important to at least talk about or look at attempting to align your organization's roadmap or timeline with your Lawson or Infor ERP with Infor's cloud-first strategy. They're investing a lot of money in their software as a service applications. Most of the development, enhancements, and features are going towards that product. So I would very seriously consider trying to align yourself with their goals as an organization in order to get the most out of your apps. There's no reason to sacrifice or lose any functionality with a move to the cloud. It could be a different way of doing something, and most times likely is a different way of doing something. But what we're finding is many of the solutions in the cloud achieve the same result as something you may be doing on-premise. And usually it's faster, more powerful, efficient, and cheaper to be running it in the cloud versus what you may have been doing on-premise. Taking advantage of managed infrastructure and serverless technologies. This just kind of goes along with the theme of software as a service model. So if you're going to move your Infor applications to the SaaS-based offering, you're offloading a lot of the support and maintenance you had dealing with your on-premise servers. So if you're going to put other things in the cloud to support Infor, I think it makes sense to look at some of the fully managed and serverless solutions so that you can continue to focus on what matters, the data, your users, and any customization or development that you're doing, and not really having to worry about the underlying compute resources, OS, patching, etc. that may have to come along with it. It's fully supported and very common to launch, virtual machines running Windows in the cloud, and that's very doable, very easy to do in AWS, and if you're, find a need for it, it's definitely supported. But then you're still responsible for managing, again, from that original diagram, everything on up from the operating system, patching it, upgrading it, so on and so forth. With the managed infrastructure, you delegate a lot of that responsibility off to the vendor. I think finally, and most important, is there's really no one-size-fits-all approach to this. I think there's a solution for everyone, but every organization is a bit different. And I think, combination of Infor and AWS provide enough options to make something work for everybody, even if it has to be done a little bit different. The AWS and Infor certified consultants we have at Intellias would be happy to talk about your organization and how AWS plus Infor could work for you. And due to the pay-as-you-go nature of AWS, it's really easy to try before you buy. You don't need to make a huge commitment in terms of dollars. Smaller pilots and prototypes of the software or the AWS services are a great, reasonable way to make sure things work before making any larger investment or decision on your future roadmap. So we'd be happy to talk to you about that if there's any further questions. Again, thank you for joining us today. This is Rob Flannery, Director of Services at Intellias. My email here is on the webinar if you need to reach out with any questions or have any follow-up. Also take any, at this point, if there are any questions, you could add them in the chat. I'd be happy to get them answered for you. Doesn't look like there's any questions coming in, so thanks everyone for your time and have a good day.